Hey everybody, this is the Renegade Mathematician here, and this is hopefully the first of many episodes in the course that I'm putting together on linear algebra. Now, if you're tuned in here, you're probably interested in learning linear algebra, but what you'll need, basic knowledge you'll need, is algebra. So high school algebra, or maybe early college algebra. You won't need calculus, you won't need trigonometry, but you will need algebra, and the other thing you'll need is you'll need to understand basic logic. So you'll need propositional logic, you'll need to understand basic proofs, you'll need to know what a proof by contradiction is, you'll probably need to know, at least eventually, what the contrapositive of a conditional statement is. Essentially, if you've had geometry, say in high school, and you had a course where they didn't take all the proven stuff out, you may be fine. And if you don't have all those, if you don't have the prerequisites, if you're not that great at algebra, or if you don't really know logic, it's okay. You can get that knowledge. You can get it as you go along. It's going to be a little bit rough going, but you can do it. Now, the text that I'm using primarily is a text by Shilov, S-H-I-L-O-V, Russian dude. And the reason I'm using that text is because it's a Dover publication, and those books are really cheap. So that's why I'm using it. Now I hope you're ready. Watch out. Here comes the first video.
Alright, we're going to start off the discussion with permutations and cycles. Well, permutations will be discussed in this video, and cycles will be discussed in another video. But to start, a definition. A permutation is a bijective function, alpha, from the set of integers 1 through n to the set of integers 1 through n. Now, if you don't know what a bijective function is, don't worry. A bijective function is a function that is both injective, that is, one-to-one, and surjective, that is, onto. Now, if you don't know what one-to-one and onto is, hopefully I'll do another video in the future, but as for now, just Google one-to-one and onto. Just knowledge of functions and sets and domain and range is something you got to know before we can talk about permutations. And continuing. When we say that alpha is injective, we mean that alpha maps each element in its domain to exactly one element in its codomain. When we say that alpha is surjective, we mean that every element in alpha's codomain gets mapped to by some element in alpha's domain. That is, alpha's codomain is its range. To recap, a permutation is a function alpha from the set 1 to n to the set 1 to n. That is both injective and surjective, or bijective. Alright, moving on. A permutation on the set 1 through n can be thought of as an ordering or rearranging of the integers 1 through n. The ordering 1, 2, 3, 4 is one permutation on the set 1 through 4, and the ordering 2, 3, 1, 4 is another permutation on the set 1 through 4. If we call the latter ordering 2, 3, 1, 4 the permutation alpha, then we are implicitly stating the following. Alpha at 1 is equal to 2, because 2 comes first. Alpha at 2 is 3, because 3 comes second. Alpha at 3 is 1, because 1 comes third. Alpha at 4 is 4, because 4 comes fourth. So basically, the permutation alpha is a function, right? You can think of it as the ordering, or you can think of it as the function. And so we started off by thinking of it as an ordering, right? And now we're going to translate that into the language of functions, right? And so we're to start off, we plug in the place, right? That is first, second, third, or fourth position, if you like. And then we get out from that function, the output of the function is the number that is in that position. So 2 is in the first position, 3 is in the second position, 1 is in the third position, and 4 is in the fourth position. Alright, moving on. It should be clear by now that we can think of permutations as both a bijective function and a sequence of numbers. In fact, it is often convenient to think of permutations as the former at one instant and the latter at the next instant. And this example should illustrate that you can go back and forth between thinking of it just as an ordering and then thinking of it as a function where convenient.